Hello guys, and welcome back to my YouTube channel. In our previous video we were discussing the concept of merge sort. We saw what is the merge sort and then see the pseudocode or algorithm for merge sort, and then we finally implement merge sort using C++. Now in this tutorial we will see quick sort. So like merge sort, quick sort is also a divide and conquer algorithm. It picks an element as pivot and partition the given array around the picked pivot. There are different versions of quick sort that pick pivot in different ways. So we can have always pick the first element as pivot, then we can achieve merge sort by always picking the last element as pivot, then we have the random element as pivot, and then pick the median as pivot. The key process in quick sort is partition function. In merge sort it was merge, but in quick sort is partition method. The target of partition is given an array and an element x of an array as pivot. Put x at the correct position in the sorted array and pull all smaller elements. Smaller than x means smaller than our pivot. Therefore x and put all greater element greater than x after x. All this should be done in a linear time. So for example, we have this array of 10, 80, 30, 90, 40 and 70, and we pick 70 as our pivot point. Now it will make a structure, tree like structure. Now all the elements which are less than 70 will be placed at the left side, and all the elements which are greater than 70 will be placed at the right side. So for example this. So after the first partition we will get this. Now again we will choose and pivot from these subtrees. In this case we choose 50. Then again all the element less than 50 will become on left and greater than 50 will become on right, and in this case right tree is empty. And same for our right partition. Element greater than 80 will become at right subtree. Now after the second partition we have a structure like this. Now we again do the partition, and this time we choose 40 as pivot. Now 13 and 10 will become will be placed on the left side because they are smaller than 40, and the right side is empty because there is no element greater than 40, and so on. It will be going until we achieve atomic values. Now let's take a look at our partitioning algorithm. There can be many ways to do partition. So the following pseudocode adopt the method given in this CLRS book. The logic is simple. We start from the leftmost element and keep track of the index of smaller or equal to element as I while traversing. If we find a smaller element, we swap the current element of array's ith index, otherwise we ignore the current element. So the pseudocode for recursive quicksort function is here. So we have our quicksort function. It accepts an array, a low and a high, total 3 parameter. If low is less than high, then the partitioning index pi of array is now at right place. So the pi is equal to partition, and then we give it an array low and high. It is a recursive. Then we do a recursive call before the pi and after the pi. Now the pseudocode for partition. The function takes last element in pivot, place the pivot element at its correct position in sorted array, and place all smaller than the pivot to left of pivot and all greater element to the right of pivot. So our partition function will accept 3 argument array low and high. Then the element to be placed in the right position pivot will be equal to arrays high, and then I is equal to low minus 1, so it is the index of smaller element and indicates the right position of pivot found so far. Then we will run our for loop, in which we will initialize j equal to low, and the condition will be the loop will keep running until j is less than or equal to high minus 1 and the j increment. So inside of this for loop we will check if jth index of array is less than pivot, then we will increment I by 1, and then we will swap the ith array and the jth array index. So now let's take a look at the illustration of partition function. Consider we have this array 10, 80, 30, 90, 40, 50 and 70. So the indexes are 0, 1, 2, 3, 4, 5 and 6, and the low is equal to 0, which is this, and the high is equal to 6, which is the last index, and pivot in this case we choose 70, the last index element. So initialize the index of smaller element I is equal to minus 1. So our pivot is 70 and our counter variable I is the index of smallest element and j the loop of variable. We start the loop with initial values. Then our test condition is jth index of array must be less than or equal to pivot, and the value of variable I is equal to minus 1 and j is equal to 0. So traverse element from j is equal to low to high minus 1. J is equal to 0 since jth index of array is less than or equal to pivot. So do I plus plus and swap these two values. Now we also create and swap function. So you can see all of this illustration for the merge sort as for quick sort algorithm. Now we will write our code of C++ for the implementation of quicksort algorithm. So let me clear all of our previous code of merge sort algorithm. First I will write our swap function. Now time for our partition function. It will be of an integer type and accept an array. A int low and a int high. Then our pivot equal to the height array, index of our array, and int I is equal to low minus 1. Now our for loop. I minus 1 and j plus plus. We'll call our swap function. Now here our swap function, and I will pass the I plus 1 index of our array and array's height index. And then our return, which will be I plus 1. Now our quick sort algorithm function call. Low is less than high, then we will create our pi. And then again our quick sort recursive calls, array, low and high. And then our high. Now our int function call. Now our main driver program, we will create an array of integer and initialize its values to the 10, 7, 8, 9, 1, 5, and we'll give it this. Size will be 5. Then we simply call our quicksort function and we'll give it our array, then our n and n minus 1. Now simply print our array. So now let's call our run our program. So you can see our array is now sorted. So this was a successful implementation of quicksort in C++. So that's all from today's video.